What if every air conditioner could fight climate change instead of fueling it? That's the promise of Microvent exhaust, a compact self-powered clip-on that captures harmful gases, grows microalgae using waste heat, and powers its own smart sensor. In short, it turns cooling into climate action. In 2024, India sold 14 million air conditioners, and by 2050, household ownership is set to rise nearly ninefold. But air conditioners don't just consume electricity, they leak HFC refrigerants, chemicals more than 2000 times stronger than carbon dioxide. Even tiny leaks are devastating. The world is facing down HFCs under the Kigali Amendment, but booming demand calls for innovation. Microvent makes every air conditioner a climate ally.
Let's move on to the elegant engineering aspect of our design. The module is just 10 by 10 by 5 centimeters, smaller than a paper bag. Here's how it works. First, it uses a Chlorella biofilm, a thin layer of microalgae that captures CO2 in sunlight, converting it into biomass. Next, it contains an activated carbon cartridge that captures HFCs, hydrofluorocarbons, from refrigerant leaks. It also leverages heat harvesting by using waste heat from the AC exhaust, usually 40 to 60 degrees Celsius, and converting it into 10 to 5 milliwatts of electricity using thermoelectric modules. Intelligent sensing is made possible by a biomass coated electrode that tracks both CO2 and HFC levels. Finally, with a small fan and thermostat powered entirely by harvested energy, the biofilm stays at its ideal growth temperature of 25 to 30 degrees Celsius. In essence, Microvent transforms waste into value. The science in action. Why algae? Because biofilms fix carbon efficiently. For every kilogram of dry algae produced, about 1.8 kilograms of carbon dioxide are locked away. And since the algae sit in a thin film, more cells get exposed to light, boosting productivity compared to traditional cultures. For HFCs, activated carbon is the hero. Depending on the form, it can absorb between zero point 0.2 to zero point 0.8 kilograms of refrigerant per kilogram of carbon. And the process is even regenerable. On the power side, thermoelectrics like bismuth tellurium modules convert small temperature differences into usable energy. That's enough to run the fans, sensors, and a storage capacitor with no need for batteries or wiring. Maintenance and usability. So, what about its upkeep? It's simple. The biofilm just needs a quick wipe each week. A nutrient top up is required once a month. The carbon cartridge should be replaced once a quarter. And the sensors need a yearly calibration. Water for the system comes from the AC's own condensate and is topped up with a nutrient sachet.
So, what does this achieve? Each module can capture CO2, absorb leaking HFCs, and generate enough power to be self-sufficient. The prototype costs around 8,000 to 12,000 rupees, but with scale, the price target is just 5,000 per unit. Payback time ranges from 1 to 3 years thanks to carbon credits, reduced service needs, and energy benefits. The bigger picture. With just 1 million units installed in India, Microvent could prevent up to 500,000 tons of CO2 equal every year, mostly by stopping HFC leakage. And that's just the beginning. This also creates co-benefits. It increases awareness, creates new jobs in cartridge servicing, remanufacturing, and provides a way to turn rising AC demand into an opportunity rather than a threat. Here's our roadmap. Between 2025 and 2026, we plan to launch residential pilots in 1,000 homes, along with setting up the supply chain. From 2027 to 28, we will integrate with OEMs, retrofit units in offices and hospitals, and release the first thin film biomass thermoelectric variant. From 2029 onward, we will scale to industrial ducts, citywide programs, and global expansion. To get there, we are seeking 3 to 5 crores in seed funding to launch pilot manufacturing, complete safety testing, and co-develop with major AC companies. With mass production, profit margins can exceed 35%. The message is very simple. Every air conditioner can fight climate change. Imagine telling your neighbor, ACs usually throw out hot air. Ours makes clean air. Or telling your kids one AC is equal to 2 tons of carbon dioxide. But we flip the story. This is not just about the technology, it's about community, awareness, and the belief that every day machines can be allies in the fight against climate change. Join us and let's turn cooling into a force for good.